From the beautiful South Studios of Way Happy, this is Mr. Meyer and 1-2 finding limits graphically and numerically. All right, let's talk about limits. This is a fun, and this is really going to get us started now on the calculus stuff where we actually get to find limits. And limits are, again, kind of think of them as your best guess, like a really good guess, because we're going to get really, really close to what we think the answer is. And I mean really close, right? In calculus, when we say we get close, we mean we get really close. So what we're going to do on this problem, I kind of want to start it off, just get you going, is remind you a little bit about pre-calc and remind you a little bit about how you solve problems, right? So I got a little intro to limits here, which it has to do with Wile E. Coyote, right? Wile E. Coyote's on a cliff, something bad happens, boom, he falls down all the way to the ground into a cloud of smoke. And we know from whatever class you've taken that there's an equation that could model the height in feet of a falling object. That's right here where I'm highlighting, right? That's the height in feet of a falling object here on planet Earth. Here, when you do feet instead of meters, you may remember this formula, but it looks a little something like this. It's like opposite of 1/2 gravity times time squared plus the initial height of the object. Now for us, physics people, you probably use 9.8 for your gravity. In math, we use the feet because we measure in feet, so we use 32 feet per second. And that's where that formula comes from. That's where the -16 comes from, is -1/2 times gravity, which is 32 feet per second. All right, now that we got that out of the way, there's our formula. So now, can we make a position function? Can you tell me the height of Wile E. Coyote when he's falling from this cliff of 900 feet above the ground? Well, yeah. I go, well, his height, S given t, is equal to -16t squared plus his initial height, or 900. Now, the cool thing about this is we are going to now find his average velocity, right? Speed is always positive, but velocity has a direction, and velocity tells us which way he's going. And so we're going to find his average velocity. And so I want to find out, if you see part B, it says, can you tell me his average velocity for 3 seconds? Well, how would you figure that out? You'd say, all right, let's see how high he is at time 0, and then at time 1, time 2, time 3, stop, right? Freeze the video. And let's see how high he is. And we'll subtract that distance, and we'll divide it by the time it took, and that would be his average velocity. So what do we have to do for this? We have to go the height at 3 seconds minus the height at 0 seconds divided by 3 minus 0, because that's the seconds. That should give us the feet, right? The top would be in feet and the bottom would be in seconds. That will give us the average velocity of Wile E. Coyote falling. So what I do, I think I still have it in here from before. So I hit y equals, and I type in the equation into my calculator. So I go to my calculator, type in y equals -16x squared minus 900. Now that is referred to as y1 from now on our calculator. So now if I want to do that actual problem that we just did, how do you pull up y1? Well, you can do it 2 ways. You can hit vars, go over to y variables, hit number 1, which is functions, and pick number 1, which is 1. That's y1. And what value do I want to evaluate it at? I want to evaluate it with a 3 in there. So parenthesis 3. See how this is just like f of x, right? Where we always say f of x is y. Well, we have y and then parentheses, the x value is a 3. So this is saying plug a 3 into y1 and tell me what you get. And here I can show you. If you see, it's -1044. All right. Now, what is that distance that he travels? So he goes y1 evaluated at 3 minus y1. Again, here's another way to get there. Alpha f4. You may have this hidden menu where you can just hit y1 at 0 seconds. That was the height. And I'll figure out what that is. So that's how far he dropped. 144 feet is what he dropped in those first 3 seconds. So we divide it by 3, or 3 minus 0, or whatever you want, and you would get -48. So Wile E. Coyote dropping at an average velocity of -48 feet per second, right? Now it makes sense. When he first falls, he doesn't right away start falling 48 feet per second. He kind of starts off really slow, and then gravity starts picking up speed. So he's getting faster and faster as he's falling down these 900 feet down the mountain or cliff or whatever. So that's why I went to the next question. I said, all right, well, if 0 to 3 seconds, the average velocity was 48 feet per second. But remember, he started off really slow and then he sped up. What's the speed between 2 seconds and 3 seconds? How fast is he traveling at that moment? So again, here I go. I'd take his height at 3 seconds minus his height at 2 seconds. So now that's just that little bit over 3 seconds minus 2 seconds. That will give me his feet per second, but at a different time, not from 0 seconds to 3 seconds, but we let him fall for 2 seconds and then we see how fast he's going. And what would that give me? Well, let's see. I go back to my calculator and I go, all right, I want to do I want alpha. Y1 evaluated with a 3. So let me put a 3 minus a Y1 evaluated with a 2. And you notice I put that in parentheses because I want to divide it. I could have just used the fraction bar. And I want to divide that by however long he's falling. And for us, it was 1 second. And so, boom, he is now going at negative 80 feet per second. So you can see that the average from time 0 to time 3 was 48 feet per second. But in that little chunk between seconds 2 and 3, he was already up to 80 feet per second. He's flying, right? All right, let's get even better. How fast is he going exactly at 3 seconds? I don't know, right? Because I would do his height at 3 seconds minus his height at 3 seconds over 3 minus. This isn't going to work. This isn't right. I don't know. So I can't do that. And that's, my friends, is what we're going to use the limit process for. We can't find that velocity, right? It just doesn't work. We need a limit in order to solve that problem. So this is what I mean by getting close. In calculus, again, when we get close, we mean really, really close. So how could we get close? Well, we could still use our same logic. We could still sit here and say, let's find his average velocity between 3 seconds and 2.5, right? So at 2.5 seconds, get his height. At 3 seconds, get his height. See how fast he was traveling. So again, here I go. I'd go second, enter. And I have 3, and now I have 2.5. So second, where's insert? I don't see it. My eyes are so bad. There it is, 0.5. So there's 2.5. And that we're not dividing by a second anymore. We're dividing by half a second. So how fast is he going? Oh, 88 feet per second. Look at that. This one is 88 feet per second. Oh my gosh. Let's shrink that time down faster and see how fast he's traveling, right? So let's go ahead and put in 2.9. So back to my calculator, and I go second, enter to recopy everything. But now let's go to 2.9 seconds to 3 seconds. What's the height? It figures it out. And that's only a 0.1 second difference. How fast is this crazy guy going now, right? And you see that it's 94.4 feet per second. 94.4 feet per second. Wait, let's get even crazier. Let's go 2.99. So it's almost 3, right? And a lot of people would call it 3. So second, enter. 2.99 second, insert another 9. That would be 0.01 seconds now. And how fast? Oh, I lost a parenthesis. That's not good. That would mess everything up, wouldn't it? Divided by 0.01. Ugh, why don't you want to give me a point? 0.1. Enter. 95.84. Holy macaroni. 95.84 feet per second. And oh my gosh, let's go 2.999 seconds. This is awesome. So second, enter, right? Copy that bad boy. Come over here. I want to insert. I see it. Second, insert 0.999. What is that? That's going to be 0.001. 0.1. Enter. 95.98. This is crazy. 95.98 feet per second. Now look, we're getting really close to the time at 3 seconds. I'll be back after this, but you can probably guess how fast he's going. So, as you saw there, before I got cut off, you can see that we can't find the average velocity at exactly t3 seconds, but we can get pretty close, or we can at least see what it is approaching 3 seconds, right? So you can see as I got closer and closer to 3 seconds, I can see that he's getting really close to a number that would be his average velocity. And that's what we're talking about when we talk about limits. We can't get the answer because you saw when up in part D, I divide by 0. It doesn't work. I can't do it. But I can get close, and I can get you a really good estimation. I bet we could do 2.9999 and 2.9999999, right? We could just go crazy. And I feel like we could get a pretty good estimation, right? So that's what we're talking about in limits. You're getting a good estimation. Now, how does this transfer to graphs? All right. So as this thing decides to not go along, there we go. How does this transfer to graphs? Well, let's say we want to sketch the graph. So x cubed minus 1 over x minus 1. It's pretty easy to graph, except for when you plug in x is 1, because you're going to get 0 over 0, just like the Wile E. Coyote problem. So what would you do? You could see the table down below. I can start going, I can get really close to 1, like 0.9, 0.99, 0.99, and you can see the y values right here, right? So as I'm plugging in 0.9, I get 2.7. 0.99, I get 2.9. As I plug in 0.999, I get 2.997. At 1, I don't know what it is. But then let's put the other side of 1. At 1.001, I get 3.003. And then 3.3. So if you look at what we call the left end behavior and the right end behavior, we couldn't figure out what 1 was. That's why there's a question mark. Couldn't figure out 1. But if we look to the left side and the right side, do you think you could make a guess? And that's what a limit is. A limit is, let me check the left side, let me check the right side, and if I think I can make a guess, I'll make a good guess. If I can't, then I'm not going to give you an answer, right? But if I think I'm pretty sure I know what the answer is, then that's what a limit's going to be. It's pretty obvious in this problem. I think it's 3. Right? Because it looks like it's going to be 3, and that's a limit. Check the two sides. Now you can do that with a table like I do right here, or you can do it with the graph right here. If you look, we can see that, remember, one thing I should say, and I haven't even said, limits are the y value. What is the y value right here? What's that y value when you look at a graph? And we want to look when x is 1. So when I come up from x is 1 right here, what's the y value? And if right there, you can see it's a hole. It doesn't exist. You're like, it doesn't exist. But what's the limit? So the limit says go to the left a little, go to the right a little. Could you make a good guess? And the table shows it, and the graph shows it, that it looks like it could be 3. And so guess what? That's how I write a limit. You can see right here. Using limit notation, I can tell people, make sure you write this the right way. This is the way you want to write it. You want to say the limit as x approaches the number 1, if I check the left side and the right side, and now you can either write the equation, which looks beautiful. You can be like x cubed minus 1 over x minus 1. Of that, as you plug a 1 in that, the limit is approaching 3. And why do I have to use a limit? Because if you plug a 1 in, it doesn't work. But if I talk about a limit, if I say as we approach it, then all of a sudden it works. So limits are when you check the left side and the right side. If you got the same, if you feel like you got a really good answer, that's going to be your answer. All right. Whew, that was a lot. Let me ask you a question and I'll be right back. All right. Nice work. Now that leads us to an informal definition of a limit that says, if you look at the y value from either side of whatever x value you're looking at, the limit is the y value at that x value. So you look at the x, right? Whatever they tell you to look at, and then you go a little left, a little right, you see what y value is, and then boom, that is the limit. All right, so let's try this example 6 that I have here that says find the limit. So again, first thing is you might be like, let's find the limit of this. Well, I need to make a table of values, right? I need to do 0, and then so I'll put 0 in the middle, and then I'll have like, I don't know, what do you want to do? 0.001 or something like that, and then 0.01 and then 0.1, and we could figure out what that is. And we could also do negative 0.001, negative 0.01, and negative 0.1. And we figure out what all those y values are, and we see what happens. Now, I'm going to use Sheila for this. I'm going to say, all right, Sheila, let's open you up and let's go y equals. Now, I'm going to hit alpha F1 for the fraction bar. And then I'm going to put x over, and then the square root of, so the square root of x plus 1. Oops, I didn't get the plus in there. Plus 1. And then I make sure you get out from under the square root, and then minus 1. So I used a right arrow, by the way. And there it is. And now I can go ahead and start evaluating this. So if I quit out and I go, all right, alpha y1, and I want to evaluate u at, I already forgot what I said, 0.001, all right, it'll tell me the answer is 2.005. Well, I guess 3 zeros. So 2.0005. And then if I evaluate you at, if I do this again and I evaluate you at 0.1, oops, 0.1, come on, 1, come on. I don't know what that was about. And I hit enter. You can see it's 2.005. And so if I continue to do this, I should be able to get a limit. Now, we don't know what it is here because try plugging in 0, you're going to get an error. And keep going. Let's try the other side, the negative 0.001. So, and then I'll let you, or maybe I'll pause it and I'll fill in the thing or something. I don't know. If I hit, oops, not at all what I wanted. Second entry, copy that thing from before if you want. And type in, I'm going to have to do negative 0.001. I get 1.9995. So down here, 1.9995. And again, you can fill it in. But look, remember what we look at? We look a little to the left, we look a little to the right, and we see if we can make an educated guess. Now, I should, yes, find some more values here, right? I should find some more values so I feel pretty good. Or maybe I should look at the graph. And you can look at the graph, I think, right here is the graph. And we were looking at when it was 0. I believe, yeah, 0. And so look at 0. You can see right about here. I don't think you can see my cursor, but at 0, it looks like it's right around 2. The y value looks like 2, but there's something weird. Look at the table. Even you can see the table in the middle of the screen that has an error at 0. So I can say that the limit as x approaches 0 of x over the square root of x plus 1 minus a 1, that is equal to what I think it is, and I think it's equal to 2, right? And I can make a very strong, educated guess. I don't feel like I'm ripping anyone off. Look at this. I mean, it has to be 2, right? You go from 1.9995, then you don't know, and then 2.0005. Come on, what number's got to be in between there? It's got to be 2. And I mean, that's why limits are so fun. They're definitely an educated guess, right? Now, why is it a guess? Because I can't actually plug in 0. But man, I'm making a really good case. And the closer you get, the better your guess would become. All right, here's the last one. What kind of, let's do a limit that could fail to exist, right? Now, what does that mean? You saw Mean Girls. The limit does not exist. There's 3 reasons why it could not exist, and that'll be in a minute. But let's look at example 2 and show you one limit that doesn't exist. So if I go ahead and try to do this, right? I don't know why I'm drawing a graph because I was going to show you graphically, but I would probably start with 0 in the middle, right? And then we should pick some stuff smaller and some stuff bigger, just like we've been doing. So again, I would pick stuff like 0.001. And so let's do but kind of think about it. This is x over x, right? So it doesn't really matter what I plug in, but we'll go ahead and just do the regular. And on the negative side, negative 0.001 and negative negative 0.01. Change colors there. That's always fun. All right, we'll leave it change colors. Plugging in 0, we get 0 over 0. That's no help. But if I put in 0.001, I get 0.001 over 0.001, that's 1. If I plug in 0.01 over 0.01, that's 1. Plug in 0.1 over 0.1, that's 1. What about the left side? Plug in this, and I would get 0.001 over negative 0.001. So I'd get negative 1. And then this one, I'd get negative 1. And then this one, I'd get negative 1. So what in fact happens is everything that you're plugging in, say this is negative 1, everything to the left of the y-axis, you would get negative 1. And then everything to the right of the y-axis, you would get positive 1. Now look at this. Both times we have issues that are causing us a little bit of fits here, right? If we look right here like we always do and say, oh, what's your best guess? Well, it's negative 1 on the left and it's 1 on the right. That's not very convincing that I know what the answer is. Yeah, you'd say that, oh, in between is 0, but no, we want the number. We don't want to guess. We don't want anything. We want to know exactly where is it headed on the left and the right. It should be the same number or really, really, really ridiculously close. And these aren't close. Negative 1 and 1 are not close, right? They're far apart from each other. So that's why all of a sudden I can't give you an answer. Or look at the graph. If I go right here at 0 and I look to the left side, I'm at negative 1. The right side, I'm at positive 1. They don't meet. That doesn't make sense. So therefore, that is a chance where the limit does not exist. And that's what that says here, right? The limit does not exist. There's 3 types. When they approach different numbers from the left and right side, or if it increases without bound as we approach. So it looks like an asymptote, right? But only a one-sided asymptote. Or maybe it oscillates between 2 numbers. It keeps bouncing back and forth. That would be another case where I cannot have a limit. So, because you can't make up your mind if it's one number and then it's 5 and then it's negative 3 and then it's 5 and then it's negative 3. I can't give you a limit because I don't know what number we're at. So that's when a limit doesn't exist. 3 cases that are there. There's 3 cases where limits do not exist. Remember, probably the most important thing is to look on either side of the number that they're asking you to evaluate the limit at, and you tell me what you think the answer is. Perfect. Have a great day. Stay happy. And I'll see you tomorrow.